Properties of parallelograms. The objective for this lesson is to be able to apply the definition of what a parallelogram is and the theorems and the properties of what a parallelogram is into either algebraic work or into proof work. So first, let's define what a parallelogram is, its definition. A parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So in our picture, AB is parallel to DC, and AD is parallel to BC. Now, when we have two sets of parallel lines intersecting each other, then all of the properties that go along with parallel lines apply. So now, the following three boxes are properties of parallelograms and not the definition of parallelograms. One property of parallelograms is that the opposite sides of the parallelogram are congruent. The second property is that the opposite angles are congruent. And the third property is that the diagonals of a parallelogram bisect each other. Now note that the two diagonals split into the two blue hash marks are congruent to each other, and the two yellows are congruent to each other. But the blue and the yellow are not congruent to each other. That property comes later in a different type of quadrilateral. So let's walk through our example. It says, in parallelogram HIJK. Now, whenever I read that phrase, or I am told that a quadrilateral is a parallelogram, then all three of the properties above and the definition of what a parallelogram is apply. So I can use any of those four things to help me solve either my equations or solve my proof. So in letter A, knowing that HIJK is a parallelogram, knowing that HM is equal to 2x plus 5, and knowing that MJ is equal to 4x minus 19, shows me that HM and MJ are both diagonals in my parallelogram. So my property that states the diagonals of a parallelogram bisect each other is what I should be thinking about in order to solve this problem, which means I can take HM, its equation, and set it equal to MJ's equation, because the two pieces or two segments are equal to each other. And as you can see in A, after we set the two equal, we solve for x. Now in letter B, it's a little more difficult to see. But again, we are told that HIJK is a parallelogram. We are told the measure of angle 2 is equal to 25. And we are told that the measure of HIJ is equal to 120, excuse me. So now, the property that we should use in order to help us solve this problem is the fact that if two parallel lines are cut by a transversal, then the same side interiors are supplementary. Now I misspoke. This is not a property. We're actually using the definition of what a parallelogram is. So I know that HIJ and IHK are supplementary to each other, which means when I add them together, they equal 180 degrees. Now, the process in which this problem has been laid out for you is a little bit more difficult, so I say let's simplify it. Problem B wants me to find the measure of angle 3. The measure of the angle that I can find at the moment is angle 4. All I simply need to do is subtract 120 plus the measure of angle 2, which is 25, from 180, and I get 35. And now, because this is a parallelogram, I know that IH and KJ are parallel. So that means that angle 4 and 3 should have the same measure because they're alternate interiors. So if angle 4 is equal to 35, then angle 3 must also be. Now the explanation for B was a little rocky, so I say let's look at it that way. So now, 1 through 4, we know that PQRS is a parallelogram. That means all of the properties and the definition of a parallelogram apply to our problem. So let's walk through 1 and 2 together. We'll pause and try 3 and 4 on our own, and I will present those answers. Number 1, if PS is equal to 5, then QR should be equal to what? Because of the properties of a parallelogram, I know that PS and QR are congruent. So therefore, if PS is equal to 5, QR must also be equal to 5. Number 2, it says if PR is equal to 20, then PX must be equal to what? If we look at PR, we see that it's a diagonal. And one of our properties of parallelograms states that the diagonals of a parallelogram bisect each other. So that means that PX and XR are congruent to each other. So that means I can take the measure of the entire diagonal PR and split it in half, giving PX the measure of 10. Now that we can kind of see how these should work, try 3 and 4 on your own. Here's the answer for number 3. QPS and QRS are congruent, therefore both are 125. And PQR and PSR are both supplementary to QPS and QRS, so I simply subtract 125 from 180 to get 55. In number 4, angles 1 and 3 are alternate interior angles, therefore they both have the same measure of 27, and PSR will have the same measure as PQR because they are opposite angles, and opposite angles in a parallelogram are congruent. Numbers 5 through 8 look a little more complicated, but again, we are using the same properties and definition of what a parallelogram is from the page before. So let's look at number 5 together. I'm supposed to find the values of A, B, X, and Y. Well, if the properties of parallelograms hold, then the opposite sides of a parallelogram are congruent. So therefore, A and B should be equal to the measures of the sides opposite them. The same holds for X and Y. If this is a parallelogram, then X and Y should be equal to the measures of the angles opposite them. Now, because Y has no angle measurement opposite it, we need to use the fact that Y and the measure of the angle 112 are supplementary to each other. So therefore, if I subtract 112 from 180, I get Y is equal to 68. Take a moment to pause the video and try 6, 7, and 8. Here are the answers for 6, 7, and 8. If you are confused as to the answer of any one of these variables, please circle the problem and we will go over it in class tomorrow. One more set, 9 through 13. Let's do 9 together. If TC is equal to 3x minus 5 and RA is equal to 25, solve for x. Properties of parallelograms tell us that opposite sides in a parallelogram are congruent. Therefore, TC and AR or RA are congruent to each other, and I can set their expressions or measurements equal to each other. Therefore, solving for x, making it equal to 10. Pause the video. Try 10 through 13. Here are the answers for 10 through 13. Again, if at any moment you are confused as to how Mrs. Richardson set up any of these equations, please circle the problem and we will go through it in class tomorrow. So 14 and 15 will be examples of proof. We won't be doing proof right off the bat by ourselves so much quite yet. So let's just fill in these blanks based upon looking at the picture and what we know about parallelograms. In 14, number 1 is of course our given. Statement 2 says or claims that angle A should be congruent to angle C. Our given told us that parallelogram ABCD was in fact a parallelogram, so therefore I can use the property opposite angles in a parallelogram are congruent. Now step 3 says that AB is congruent to DC. This again is another property of parallelograms. Opposite sides in a parallelogram are congruent. Now, in our given, we were told that angle 1 and angle 2 are congruent. Now my proof wants me to state where are the congruent triangles. If I go back and look at my picture, I can see triangle ABX and CDY have been proven to be congruent by angle side angle. And now, if I look at my two segments, AX and YC, they are both corresponding parts in my two congruent triangles, therefore giving my last reason as corresponding parts of congruent triangles being congruent. Right, number 15. Number 1, let's just simply make this easy for ourselves. Because they're notes, we can skip writing in the given. However, let's mark it in our picture. Now we're also told that WX is congruent to ZY. I'm using again properties of parallelogram. See if you can finish this proof on your own. The answers will follow. Pause now. We will be talking about this proof tomorrow in class, but look at 4 and 7. These are old reasons that we used in justifying statements for parallel lines crossing with a transversal. Isn't it nice that we can still use them now that we're talking about parallelograms?